All right, so earlier, those examples we've done were for binary ionic compounds. So if it's binary, only two elements involved, then you would just write it like how we did before. But if there are multiple elements involved, that's when you have to think about the polyatomic ions that you've had to memorize. So remember, polyatomic ions have different elements involved, but overall together, they have that charge. So NO3 altogether has the -1 charge, whereas earlier something like magnesium, just that element by itself, had that 2 positive charge. So remember, this is the list of polyatomic ions that hopefully you have already memorized. You have to know this to be able to name any of these compounds. So here is how you write the formula, but I think it's always easiest if I just show you instead. So you can pause and read through it if you'd like. So let's go ahead and write out the ionic compound formula knowing these are the polyatomic ions. So here this is zinc sulfate. So we just write out the ion involved with zinc sulfate. So I know zinc is Zn with a 2+ charge, and this is just something you had to have memorized. Remember the first slide over here, zinc is a 2+ charge right there. So that's how I know when I go back to my examples, zinc is a 2+ charge. And then the sulfate is something that you had to have memorized. Sulfate is SO4 with a 2- charge. And so if I'm going to go ahead and combine them, the way we do this is still exactly the same. We are just trying to balance the charges to become neutral. So when I combine the two, it's a 2+, 2-, so I just need one of each. So keep in mind, I just need one zinc and I need one sulfate. So when the two combine, that 2+ is going to cancel with 2-. So look at how SO4 is sulfate. So that subscript does need to come because 1 sulfur and 4 oxygens is what makes it sulfate. So I need 1 zinc and 1 sulfate, SO4. So this is the formula when zinc and sulfate come together. So let's try it again with magnesium nitrate. Magnesium is in the second column of the periodic table, so it's a 2+ charge. And nitrate, hopefully you have that memorized as well, as NO3 with a -1 charge. So this is where it's a little bit more different than what we did previously. 2+ charge to balance with a -1 charge. That means I need double the amount of nitrate. And remember, this whole thing is a -1 charge. So I need to tell myself that there needs to be 2 of these to balance the 2 positive of magnesium. So regardless, I still only need 1 magnesium. And I need to say I need double the amount of NO3. So that's where we come into a kind of an issue. So if I need 2 of something from before, I just put a subscript 2 at the end. So remember before when it was just magnesium chloride and we needed 2 chlorines for that 1 magnesium, I just put a 2 at the subscript. Well, this comes into a problem because if I put NO3 and I just put a 2 at the end there, that makes it look like NO32, which means there are 32 oxygens and 1 nitrogen. And so this does not work. You can't just put a 2 at the end of this nitrate because that makes it too crazy. So the best thing to do to say this entire NO3, so NO3, this entire thing, so I would put that in parentheses, I need 2 of, so I put the 2 outside of the parentheses to let people know nitrate is 1 ion, and I need 2 of those, so I put 2 on the outside of the parenthesis like this. So this would be the completed formula for magnesium nitrate. So let's try again with barium phosphite. So barium, as you know, barium is a 2+ charge. It's in the second column of the periodic table. And phosphite is PO3 with a 3- charge. So as I know, I need to balance these charges here. So to figure out what to balance, remember, we think what is the common number between 2 and 3. And from earlier examples, we know that 6 is the common number between 2s and 3s. So I need to turn that 2 positive into a 6. I know I need to multiply this by 3 to get a 6 and PO3 by 2 to get a 6 from the 3. So what I'm basically saying is barium, I need 3 of, so I put a 3 there. And the phosphite, I need 2 of those. But remember, phosphite is a polyatomic ion. So we're saying this entire polyatomic ion, PO3, I need 2 of. And so this is the correct formula for barium and phosphite. A common question I get is, can you distribute the two? So can you say Ba3 and then can you distribute this 2 and say 2 phosphoruses and 6 oxygens? So can you write Ba3P2O6? And I'm going to go ahead and say I would not recommend doing this because later when I talk about chemical bonding and the shapes and structures of the chemical compounds, it would not be helpful for you to write it this way. This is actually going to make it worse and more harder and difficult for you in the future. It's best to just leave it the way it is in the parenthesis like so. So if you wanted to go ahead and pause the video here and try the rest of these on your own, you can, or you can just wait and I will go ahead and upload the answers in about 10 seconds. All right, so here are the answers. Another question that I sometimes get is for something like this, NaCN that is using a polyatomic ion, can you write it Na parentheses Cn and just not have a number or, just leave it like that with the parentheses? And I would not recommend that because that's kind of weird. It's kind of like if someone were to write NaCl and then put Cl in parentheses like this. It's very unnecessary. I guess if I gave you a more ridiculous example, like my name is Ji-sun Kim, and if I told you I'm going to write my name like this, yes, you could still read it normally, but it just looks silly. And so when there's no parenthesis needed, I would not recommend doing that. It's just silly. All right, so now let's try going backwards. So once you see the compound formula, how do you read the correct name for that? And to do that is you literally, like I said, if it's a cation, you read it just like what it says. So any cations, we're gonna read the name of the metal first. And then the anion is, if it's a polyatomic ion, there's no need to change the name. You read it like how it is. But if it's a monatomic ion, remember to change the ending to an IDE ending. So really polyatomic ion, leave it alone. Monatomic ion, change the name. So like if I looked at this first example here, MgPO42, you need to be able to recognize the cation and the anion. And I recognize that magnesium is the 2+ cation and this PO4 is the 3- anion. Okay. So remember these subscripts 3 and the 2 came from balancing the 2+ and the 3- charges that we wrote out here. So that's why we ignore the 3 and the 2 when we're trying to figure out what are the cations and anions for now. But this 4 we can ignore because this 4 is from PO4, phosphate. Phosphate is only phosphate because it has the 4 oxygens. So that means this is our cation. And the cation, we just read it like normal. So always cation, we read it like how it normally is, magnesium. And then phosphate, you have to determine, is this a monatomic ion or a polyatomic ion? And I know this is a polyatomic ion, so we read the name just the way it is, and I'll read it as phosphate. So this would be read as magnesium phosphate. Looking at the next one, this one looks super crazy, but remember, it's just all about can you recognize the polyatomic ions. So I know that this is the first polyatomic ion, ammonium, and the second one is the dichromate. And since, remember, the first cation, we always read it like how it's just read, it's ammonium. And the second anion is also a polyatomic ion. Remember, all polyatomic ions, we read it like how it normally is. So it's just dichromate. We don't need to change anything about that one. So let me go ahead and do the rest of the 3 just real quickly, and then let's do the last one together. So doing this last one together, this is ammonium. And then this is the other anion, chlorine. Right? So as we can tell, this is our cation this time. So our cation, we still read like normal. So cations, we just read the way it's read. So it's ammonium. But this is now chlorine. This is not a polyatomic anymore. This is now a monatomic ion. So remember, monatomic ions, we have to change the name. So chlorine, we just take the first syllable chlor, and then we change it to chloride. So this would be ammonium chloride. So just keep in mind, if you're ending with a monatomic anion, change the ending to an IDE ending.